Okay guys, let's begin. What I'm going to show you here today guys, just a bit about density, okay? So, an example would be, even before all this, I'm just going to run this over density, okay? Now, density is the mass of an object per unit volume, so you probably know this from, physics, okay? Mass over volume. So an example would be the density of water, raw water, is the density of water is 1,000 kilograms per meter cubed. You would know this is 1 gram per centimeter cubed. Is everybody alright with that? Now, if I wanted to find out theoretically, let's say there's a cylinder of water. Okay, so the cylinder is here. I'll do it in meters just to keep everything calm and cool. So we have a cylinder here. It's of radius 1 meter. So we have 1 meter here. We give it a height of 3 meters. What is the mass of this said object? Okay, given that it's entirely made of water. Hypothetically, it's made of water. Okay. So what we do here is to get the mass of the object, we'd multiply it by rho times the volume. The volume times the density gives you back the mass. Basically cross multiplying back across phi by rho equals mass. So if I want to find the mass of this object, it'll be 1,000 kilograms multiplied by the volume of a cylinder, which will be pi radius squared, which is 1 squared times height, and wherever that's going to turn out to be 3,000 pi. Is that right? Now guys, what I'm going to say next is there's another word called relative density. Relative density is always in direct comparison to water. If I said I now made the same objects, except this time it's made of, I don't know, like a hard plastic or a metal, okay? And the metal is of relative density 2.8. Now, do you know what relative density 2.8 means? It means 2.8 times the density of water. So rho would be 2,800 kilograms per meter cubed. Does that make sense? Therefore, if it wants the mass of the same object, this time it's made of, I don't know, some form of metal. If I want to get the mass of this, what we're then going to do, if I want the mass of this, what we're then going to do is we're going to basically say, okay, the mass of this object is once again volume times density. So volume is going to be, once again, it's going to be pi times 1 squared times 3 times density, which is going to be 2,800. And whatever that turns out to be, what's it going to be, guys? 3 times 2,800? Anybody? Is going to be 8,400 pi kilograms, okay? So that's how relative density affects, that's how you calculate a density from relative density. You just multiply 1,000 kilograms per meter cubed by whatever density is there in question, okay? So, going to do next, guys. Just 1 second. There we go. Okay, so what we have next is what is buoyancy, okay? So buoyancy is an example is when you submerge an object in water, it experiences a buoyancy force, okay? So if I was to take this cylinder, okay, and I was to submerge it in water. Now first of all, you can only the object has to be made of a material that's less dense than water. Does everybody understand that? Has to be less dense than water to float in water. So your relative density of the object that you're floating in the water has to be less than 1. It can't be the same density as water. It has to be a smaller density than water. Does that make sense? Okay. So an example would be, I'm looking for the buoyancy force when I submerge it 2 meters. I submerge the object 2 meters underneath. Okay, so 2 meters. I'm 2 meters submerged. Okay, This means your buoyancy force, we'll call it B dash. Your buoyancy force is how much water have you displaced. What is the volume of water that you're pushing out because your volume is underwater? So it's going to be, in this case, it's going to be pi r squared. We'll call it x. We'll call x how much of your height is buried beneath water. Okay? So buoyancy force is your volume multiplied by rho. Okay? And then it's also going to be multiplied by g. Because remember, force equals mass times gravity. It's equal to the weight, lads. It's equal to the weight of water that's displaced is your buoyancy force. So buoyancy is going to be, in this case, it's going to be pi times 1 squared multiplied by 2 because that's how much water you displaced. Then it's going to be multiplied by your density, which is 1,000. And then that's going to be times gravity. And that will give me, what's it, 2,000 pi g newtons. Because it's a unit of force. Okay? Now, where does this slide in with a simple harmonic motion? First of all, I'll start us on the example that's in the book, okay? So the example that's in the book is basically a cylinder of radius r and height h has relative density s. What does relative density s mean again, guys? S multiplied by the density of water. So once again, the density of water, raw water, is 1,000 kilograms per meter cubed. So therefore, our rho, what's it made of? Just rho object, we'll call it. The density of our object is going to be 1,000 s kilograms per meter cubed, because you have to multiply by the relative density. If s was equal to 2, it'd be 2,000 kilograms per meter cubed. If s was equal to 0.6, it would be 600 kilograms per meter cubed. It all depends on the s value. Now in this question it doesn't actually give us the s value. Is flowing in water with its axis vertical. Is then depressed vertically a further small distance into the water. So basically it's dragged down a little distance x. And see this little cylinder here. That's the volume of water that's displaced. Okay? And therefore that's going to be giving us our buoyancy force that's bringing us upwards. So your weight always acts downwards, but your buoyancy force will balance you going upwards. Okay? We're going to say that the displacement x is in a positive direction. Therefore, because the buoyancy force is acting upwards, we now say that the buoyancy force equals minus volume times density times gravity. Please remember, volume times density is in fact your mass. Mass times gravity is weight. Okay? The weight of the water displaced. Now, here we go. Okay, so show that it will perform simple harmonic motion and find an expression for the periodic time. Okay, buoyancy force is the weight of the water displaced. Okay, so it was balanced at the start of the question. Then we brought it a further distance down, like this, a further distance down, and now there's extra buoyancy force forcing us back up again. So we have extra buoyancy force that's actually contributing to us going upwards. Let's find the amount of extra buoyancy force. So it's the shape of a cylinder, so it's minus pi r squared h, but the height is the little distance x. Our rho value is going to be 1,000, because please remember we're displacing water, we're not displacing the mass we're not displacing the material that's in the object. Buoyancy is the weight of the water, not the weight of the object. Times gravity, g. Then what we're going to get is minus 1,000 pi r squared x g. Okay, that's our buoyancy. Okay. Next thing I gotta do is to do a simple harmonic motion. F equals ma. force equals mass times acceleration. My whole job is to end up with a system where A equals minus omega squared x. So I need to find the acceleration on its own somehow. So I'm going to link buoyancy in. Buoyancy is the force. Now I'm going to have to find out what the mass is. Now the mass of the full object is its volume multiplied by rho. Volume multiplied by density gives you mass. Okay? Its volume is pi r squared h, where h represents the height of the full object. Its density, remember, it's not the same as water, which was 1,000. It's 1,000 s, because it's lighter than water if it's floating. Therefore, the mass of the object is going to be 1,000 pi r squared h s. Okay? Now we're going to equate them both together. It's going to be the buoyancy force, which is minus 1,000 pi r squared xg, equals the mass, which is 1,000 pi r squared hs, multiplied by acceleration. Now you're going to enter a bit of a cancel off fest here. Lots of cancelling off. Isolate A on its own. A equals minus xg over hs. Okay, so minus xg over hs. Now remember, A equals, I'm going to put the x at the end, minus g over hs x. We're now going to compare that to A equals minus omega squared x. Is it executing simple harmonic motion? Yes, because the acceleration is directly proportional to the displacement. Yeah? And it's in the opposite direction because of the minus sign. Okay? So what's going to happen here is omega squared equals g over hs. Therefore, omega is equal to square root of g over hs. Question asked me for the periodic time, right? Periodic time. So the periodic time, t equals 2 pi over omega, which is going to be t equals 2 pi over root g over root hs. Do you see what I did there? Just broke it up into two separate thirds. You're allowed to do that. Then I'm going to turn the bottom one upside down. So it's going to be t equals 2 pi root hs all over root g. Everybody happy with that? Cool.